In this video, I will be talking about graph data structure in Python. So a graph is something that has vertices and edges. And here we see an example of 1, 2, 3 vertices, and they're connected in this way. And there's usually two ways to express a graph. One is using adjacency matrix, like we see here. And another one is adjacency list, which we will program in a little bit. So with the adjacency matrix, we have 1, 2, 3, and 1, 2, 3, and it shows how they're linked. So if you look at the one vertex, you see that it's connected to 2 and 3, so there's a 1 in those spots. The 2 is connected to 1 and 3 is connected to 1 and 2. And you can also read it horizontally. So I color them red, red, yellow, yellow, blue, blue to show that it's adjacent. And it's pretty much like a mirror along the diagonal. Okay, so here we're going to implement a graph for the adjacency list. We're going to have a class called graph here. And inside we're going to have a constructor. And we're going to have a self.graph. And we're going to initialize the empty dictionary. Then we'll have a add vertex, pass in self and vertex. So inside, we're just going to use the vertex as a key and then initialize the empty list. So self.graph and then vertex is going to equal an empty list. And then whenever we specify the edges, which is how the vertices are connected, we will append to that list. So you can have a add edge function here. And pass in self and v1, v2 for the two vertices. Then we're going to do self.graph and then pass in the key v1, and then you're going to append the opposing vertex. And if we repeat this, we're going to do v2 here and then v1. So add each other to their list of edges. And let's have a print function here. So have a print graph, pass in self, and then for key and value in our graph items, we want to print the key and then the value. So this just makes it a little bit pretty when I print it out. So we could have a if name equals main, and this will be our main test function. And let's just make a graph called my graph. And we want to add some vertices. So I'm going to do my graph dot add vertex, and I'm going to have 1, 2, 3. And we're going to specify the edges. So my graph dot add edge. And we can see edge here. So you can see 1 is connected to 2 and 3. So here what we're going to do is going to add edge. Let's do one at a time. So we could do edges 1 and 2, edge 2 and 3, and edge 1 and 3. So pretty much we specify the two vertices that form the edge. Okay, so we're going to have 1 and 2, and then here we have 2 and 3, and then 1 and 3. Okay, so those are our edges. And then after that, we want to print it out to see if it's correct. So my graph.print graph. So if I run this, you can see that it prints it out, right? So we could verify that here we have 1. So it's saying that 1 is connected to 2 and 3, which is true. 2 is connected to 1 and 3, which is true. And then 3 is connected to 2 and 1. Okay, so we see the output is correct, and that's our print graph. So we can also add a few more functionalities, like let's say we want to remove something. So let's have a def remove vertex, and we'll pass in self and vertex. Okay, and then inside we'll have a if vertex. If it's not inside the dictionary, then what we want to do is maybe return a message like invalid vertex. Otherwise, if it's in there, we're just gonna delete it. So self dot graph, we're gonna delete the self dot graph, passing in the key value vertex, and we want to remove all the edges that were specified. So for key value in self dot graph dot items, I'm gonna say if the value is in the value, okay, if the value or vertex, sorry, if the vertex is in the value, what we want to do is remove it. So value dot remove, and then pass in the key vertex. Okay, so we could do some examples and print out if we were to remove something. So let's have a new one here. And then I could do my graph dot remove vertex, and let's say remove one. Then maybe we want to print it again. We could see how it gets updated. So if I run this, you can see that one was gone, then two is connected to three, and three is connected to two. So that's what we're expecting. Okay. And we could add a few more functionalities. Maybe we want to get the vertex or get the edge. So we could have a def get vertices, pass in self, and we could return a list of the graph keys. Okay, and then we could also do get edges, pass in self, and then the vertex, which is our key, and then just return self.graph and pass in vertex. Okay, so this will give our edges. And we could print out, for example, print vertices, and then my graph dot get vertices, and we could print edges for, let's say, vertex 2, and I could print my graph dot get edges, and then pass in 2. Okay, so if I print this, I should see my results. Let me clear this so you could see better. So if I run this, you could see that vertices 2 and 3 exist, and then edges for 2 is 3. Okay. And yeah, that's how you implement a graph in Python. If you found this video helpful, give a like and subscribe, and I'll see you in the next one.